So here is 1,2-dichloroethane. Actually, there are two different molecules that can be described by 1,2-dichloroethane. These molecules are diastereoisomers of each other because you can't have rotation about this double bond. So we need a system to unambiguously identify these two different molecules. And that's the EZ system. So let's look at this one first of all. The first step in this system is you look at one end of the double bond first, and you look at the two groups attached to that carbon. And there's another atom down here, a hydrogen. Now out of these two, chlorine has the higher priority because chlorine has the higher atomic number. So we've assigned priority to the two groups at this end of the double bond. Next we look at this end of the double bond. And once again there's a hydrogen there that I didn't draw previously. So now comparing hydrogen with chlorine, chlorine has the higher atomic number out of these two, so this is the higher priority group at this end of the double bond. Now, you look at the two high priority groups. In this case, they're far away from one another. And when they're far away from one another like this, we call that E, from the German entgegen, meaning opposite. So this is E, 1,2-dichloroethane. Let's look at this isomer now. We'll go through the same process. First of all, we'll look at this end of the double bond. Once again, there's a hydrogen down there that I hadn't drawn previously. Now we've got to, at this end of the double bond, we've got to compare the two substituents, chlorine versus hydrogen. So chlorine has the higher priority, and at this end of the double bond, we've got to compare chlorine versus hydrogen, so chlorine has the higher priority. Now if you look at the two high priority groups, they're close together on the same side of the double bond. And when they're close together like this, we give that the label Z from the German zusammen, meaning together. So that's the EZ system for unambiguously naming diastereomers.